If it is a squirrel cage induction motor, then supply is only possible onto the stator side, because the 3 terminals are available only onto the stator side. Rotor side we have no terminals available. Rotor side is basically shorted by the end rings. However, in case of slip ring induction motor, the supply can be given to stator or it can be given to rotor. So I am dividing in 3 different cases to understand operating principle of 3-phase induction machine and actual operations and all parameters during the operations of 3-phase induction machine. The first case is supply is given to stator. Later on we talk about supply given to rotor, and stator is shorted. Moreover, I also move one step ahead and talk about what happened if the supply is given to both stator and rotor. So let's first discuss about the 3-phase supply given to stator. Now, this is the chapter where you are going to fall in love with induction machine. Please see. 3-phase supply is given to stator, and a rotor will have complete circuit. Rotor will have complete circuit. Is it okay? Yes, sir. Either through the external resistances or through the end rings. So when a 3-phase supply is given to stator, and rotor will have a complete circuit. Please observe. Suppose we have a 3-phase stator. I am indicating here. We have a 3-phase stator. So when I am saying 3-phase stator, it means stator windings are being displaced by 120 degree in space. So let us suppose A phase, B phase and a C phase. Rotor will have a complete circuit. Again, I am assuming that we have a rotor. Let us suppose for a moment that rotor is also having 3 phase. I am considering it to be the slip ring type. So the phases are A phase, B phase and a C phase, and rotor terminals are shorted. The end rings are being shorted. Okay. Yes, sir. The rotor terminals are shorted. A, B, C terminals are shorted. Supply is given to 3-phase stator side. 3-phase supply at F1 Hertz. 3-phase supply at, say, F1 Hertz. I am considering the stator side frequency of supply as F1 Hertz. We have a 3-phase stator as well as 3-phase rotor also I am considering. So stator is connected with a 3-phase supply and rotor is shorted. It can be a case of a squirrel cage induction motor supplied from the stator. Okay. It can be a case of slip ring induction motor supplied from stator, and rotor will have complete circuit. We all know that when a 3-phase stator displaced in space by 120 degree is supplied by 3-phase current displaced in time by 120 degree, then a rotating magnetic field is produced, which rotates onto the stator body, in the air gap at synchronous speed. So I am writing here, please observe, speed of stator field with respect to stator body. Please help me to write this. Body means winding. Whenever I am saying body, it means winding only. Whenever I am saying body, it means winding only. So speed of stator field with respect to stator, speed of stator field with respect to stator winding. Whenever I am saying stator winding, that is same as stator body. Body and winding both are same. Okay, because windings are on body only. So what is the speed of stator field with respect to stator body? Sir, stator body will remain stationary. When a three-phase supply is given to stator, then a rotating magnetic field is produced, which rotates in space at synchronous speed, which rotates on the rotor body at synchronous speed. So the speed of stator field with respect to stator winding, speed of stator field with respect to stator winding will be ns. The direction of rotation depends upon the phase sequence of supply. Let us suppose the phase sequence of supply is such that it is rotating in a clockwise direction. Okay, so CWD means clockwise direction. Speed of stator field with respect to stator winding or stator body. Please see, please see. Let me show you. Suppose we have this as a stator. Okay, we all are aware, sir, in case of three-phase supply to stator, what happens, sir? Sir, there will be a rotating magnetic field when a three-phase stator being supplied by a three-phase current displaced in time by 120 degree. So, sir, when a three-phase stator displaced in space by 120 degree is being supplied by three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced. This rotating magnetic field is rotating with respect to rotor winding at a speed of ns. This is the speed of stator field. Ns is the stator field, north and south. This north and south is rotating at synchronous speed with respect to stator body. So stator body is stationary and field is rotating. Stator body is stationary, only the field is rotating. Okay. So when a three-phase stator displaced in space by 120 degree is being supplied by three-phase current displaced in time by 120 degree, then it will create a rotating magnetic field, and the speed of a rotating magnetic field with respect to stator structure, stator body or stator winding is ns. Let us suppose it's a ns in a clockwise direction because the direction of rotation depends upon the phase sequence of supply. Already we have the complete feeling of that. Okay, sir. Now please observe. While revolving round to the stator, it cuts the rotor conductor. Yes, sir. While revolving round to the stator, it cuts the rotor conductor and it induces EMF in the rotor conductor. Yes, sir. Please observe. Please observe. This will be your rotor. Yes, sir. This will be your rotor. And this is a rotor conductor. A phase, B phase and C phase. Please observe. Please observe. Please observe. A phase, B phase and C phase. This is your stator field. Yes, sir. So when stator field rounds the stator, when stator fields rounds around the stator, it cuts the rotor conductor. It cuts the rotor conductor. It cuts the rotor conductor and induces EMF in rotor conductor. As per the Lenz's law, the induced EMF in rotor conductor causes rotor current, and the direction of rotor current will create magnetic field in such a direction that it will oppose relative motion between field and winding, and therefore your rotor will get started in the direction of rotating magnetic field. Please observe here. So when stator field is rotating, while stator field is rotating round to the stator, it cuts the rotor conductor like A phase, then it cuts to B phase, then it cuts to C phase. While stator field revolving round to the stator cuts the rotor conductor. If you assume, if we have this field like a solid, you can say wooden stick, and if I am trying to rotate, what happened? If they are going to cut these conductors, so they hit this conductor and try to rotate this conductor in the direction of movement. The same thing is happening again here also. When field is moving in clockwise direction, it cuts the rotor conductor, and rotor conductor, and there will be an induced EMF on rotor conductor which opposes the relative motion between stator field and rotor conductor. So rotor will start moving in the direction of rotating magnetic field. Is it okay? So let us suppose the rotor will be started rotating in the direction of rotating magnetic field at a speed of nr. Okay, sir. So let speed of rotor be nr. Let speed of rotor be nr. Definitely it is in a clockwise direction as per the Lenz's law. What is the value of nr, sir? It may be 0, maybe equals to ns, maybe half of the ns, maybe half of the 1/4 of the ns, 75% of the ns. It can be anything. I'm just taking it nr. Okay. So let speed of the rotor be nr, but it is in the direction of rotating magnetic field. Is it okay? Yes, sir. Now please tell me, what is the speed of stator flux? What is the speed of stator flux with respect to rotor body or rotor winding? Have you noted up to this part? Please note up to this part. For case 1, when supply is given to stator, speed of stator field with respect to stator body or winding, and as per the Lenz's law, there will be an induced EMF onto the rotor, and rotor will be started in the direction of rotating magnetic field. So it is rotating at a speed of nr, suppose in a clockwise direction. Okay. Now please observe. Speed of, please help me, speed of stator field with respect to field or flux, both are same thing. Okay. So speed of stator flux, or you may write speed of stator field with respect to, WRT means with respect to. So speed of stator field with respect to rotor body. When I am saying rotor body, body means winding. So you can say structure, body or winding, all the things are same. With respect to stator, with respect to rotor body. Please help me. Speed of stator field with respect to rotor winding. Now please observe. I am just going to open the machine. Okay. Now please observe. This is your stator. Stator can't move. This is your stator. Stator can't move. Okay, sir. Stator can't move. So I am fixing that stator can't move. Okay. Stator having 3-phase winding, on which 3-phase supply is given of frequency f1 Hertz. So when you have given a frequency of f1 Hertz to the 3-phase stator displaced in space by 120 degree, stator creates a stator rotating magnetic field. Let us suppose this stator rotating magnetic field to be represented by this person. Okay, this is a stator rotating field. I'm representing it one pole, say north pole. Okay, yes, sir. So this stator magnetic field is rotating with respect to rotor structure at a speed of ns. Yes, sir. While revolving round to stator, it cuts the rotor conductor. And therefore rotor will get started in the direction of rotating magnetic field. Say rotor will get started in the direction of rotating magnetic field at a speed of nr. So when rotor is moving at a speed of nr, then what is the speed of stator field with respect to rotor winding? Please observe. Stator field is moving at a speed of ns. Rotor itself is moving at a speed of nr. So if rotor is moving at a speed of nr and field is moving at a speed of ns, so what is the relative speed between stator field and rotor winding? Sir, ns minus nr. Is it okay? This is the speed with which rotor body is slipping out from stator magnetic field. Now let us suppose, only suppose, okay, Let us suppose if my head is the rotor conductor and there is a pole which is moving on the front direction, in this direction, okay, forward direction, by holding one stick. So if the stick is going to be in contact with the head, then head, sir, I am supposed to move ahead. Yes. So your rotor will start moving in the direction of rotating magnetic field. Is it okay? But still it is not moving at synchronous speed. It can't move at synchronous speed, because if it is moving at synchronous speed, there will be no rotor current, there will be no rotor pole. It always rotates at a speed less than synchronous speed. So that is why I have represented ns minus nr. Up to this part, everything is clear. So this is your ns minus nr. Of course, this ns minus nr is your slip speed, that is SNS. Already we have observed in the last lecture this SNS. Yes, sir. So ns minus nr is your SNS, called as a slip speed. Great, sir. Now please observe. 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 Sir, we are able to understand there will be an induced EMF onto the rotor. There will be an induced EMF onto the rotor. First, it cuts A phase. So there will be an induced EMF on A phase of the rotor. After 120 degree in time, it cuts B phase maximum. So there will be a maximum induced EMF at B phase. And after 120 degree in time, the induced EMF is maximum at C phase of the rotor. So induced EMF of the rotor is time displaced by 120 degree in A phase, B phase and C phase. Is it okay? Yes, sir. Now please observe. I am interested to understand frequency of induced EMF. So frequency of induced EMF. Now please observe. Frequency of induced EMF in rotor in a rotor winding due to stator field. Please help me. Frequency of induced EMF in a rotor winding due to stator field. Sir, we have observed frequency of induced EMF is always equals to P delta N by 120, where delta N is the relative speed between field and winding. Which field and which winding? Sir, stator field and rotor winding. What is the relative speed between stator field and rotor winding? Relative speed between stator field and rotor winding is SNS, sir. So you can write P into SNS by 120. We all are able to understand this, sir. Sir, the stator field is also rotating with respect to stator body. So there must be an induced EMF onto the stator body, stator winding also. Yes, sir. There must be an induced EMF onto the stator winding also. So let's talk about the induced EMF onto the stator winding. Please observe. Frequency of induced EMF. Frequency of induced EMF in stator winding due to stator field. Please help me. Frequency of induced EMF in stator winding due to relative motion between stator field and stator winding. Sir, this will be equals to P delta N by 120. What is delta N? Relative speed between field and winding. Which field and which winding? Sir, stator field and stator winding. What is the relative speed between stator field and stator winding? What is the relative speed between stator field and stator winding? The relative speed between stator field and stator winding is NS, sir. So you can write, sir, P NS by 120. What is NS, sir? What is NS, sir? 120 F by P. So what is NS, sir? What is NS, sir? 120 F1 by P. What is NS, sir? 120 F1 by P, where F1 is the supply current frequency in a stator? Yes, sir. So you can write P ns as 120 F1 by P. Can I write in this way? Yes, sir. Yes, sir. So it means frequency of induced EMF in stator is the same as supply frequency F1. Yes, sir. Frequency of induced EMF is same as supply frequency F1. Now please observe equation 1 and equation 2. Let it be equation 1 and equation 2. Let it be equation 1 and equation 2. Please observe, this is the greatest thing that I don't know how at that particular time scientists were able to see this. Please see, please see. You are going to feel this most important part from equation 1 and equation 2. Can I write F2 by F1? Yes, sir. F2 by F1. F2 by F1 will become P into SNS. P into SNS by 120 upon P into NS by 120. So everything will get cancelled out. SNS is nothing but NS minus NR upon NS. So this will become slip. Great, sir. Frequency of induced EMF in the shorted winding is a slip times of frequency of supply. Frequency of induced EMF in the shorted winding is a slip times of frequency of supply. I know you are unable to understand this, but this is the greatest thing. Soon I am going to elaborate it. Please observe. So frequency of induced EMF is a slip times of frequency of supply. Frequency of induced EMF is slip times of frequency of supply. Up to this part everything is clear? Up to this part everything is clear? Yes, sir. So can you please tell me what is the frequency of current flowing in the rotor winding? Sir, F2 is the frequency of current flowing in the rotor winding. F2 is the frequency of current flowing into the rotor winding. Rotor winding is also, sir, we have considered rotor winding is also 3-phase. And induced EMF in the rotor winding is, sir, induced EMF in the rotor winding is, first it cuts A phase. After 120 degree in time, it cuts B phase. After 120 degree in time, it cuts C phase. So A phase current will become maximum. After 120 degree time, rotor B phase current will be maximum, and after 120 degree time, rotor C phase current will be maximum. Yes, sir. So it indicates there will be a rotating magnetic field produced by the rotor winding also. Is it okay? Yes, sir. There will be a rotating magnetic field produced by the rotor winding also, sir. Rotor winding also we have considered to be 3-phase. Okay. Yes, sir. AA dash, BB dash, and CC dash. Okay. Yes, sir. So when AA dash, when induced EMF in AA dash is maximum, current in AA dash is maximum, that will create a magnetic field, and the direction of magnetic field as per the right hand curl rule will be this direction, sir. So the flux is here. After 120 degree in time, your induced EMF at BB dash will be maximum. Yes, sir. So when BB dash will be maximum, your flux will be at this position, and the magnitude of the flux will remain 3/2 phi m. And after 120 degree, when current in CC dash will be maximum, then when CC dash will be maximum, then flux will be here. So this flux is rotating. This flux is rotating. Sir, this flux is rotating. With respect to the body, this flux is rotating. So it can be clearly observed here. If we are representing it as north and south, then there will be a rotor field which is rotating with respect to rotor body. Is it okay? Please tell me if you are able to understand this. This is a rotor field which is rotating with respect to the rotor body. This is a rotor field which is rotating with respect to the rotor body. At this particular time, when A phase is maximum, north and south are here. After 120 degree, when B phase is maximum, north and south are here. After 120 degree, when C phase is maximum, north and south are here. So the rotor field is also rotating with respect to rotor structure. Rotor structure itself rotates, rotor structure itself rotates, and with respect to rotor structure, there will be a field which is rotating. What is the speed of this field? It depends upon the frequency of current in the rotor winding. What is the frequency of current in the rotor winding? Frequency of current in the rotor winding is F2, sir. Frequency of current in the rotor winding is F2, sir. So, sir, you can write, since rotor is three phase, rotor winding, since rotor winding is displaced in space by 120 degree, and current in rotor is displaced in time by 120 degree. Current in rotor is displaced in time by 120 degree. Thus, current in rotor is displaced in time by 120 degree, having frequency F2, Thus, rotor produces rotating magnetic field. Is it okay? Yes, sir. I am interested to understand what is the speed of this rotating magnetic field. So, speed of rotor field. Please try to understand. You are going to love this subject. Speed of rotor field with respect to rotor body. What is the speed of rotor field with respect to rotor body? Sir, in rotor body, current having frequency F2. So, if the current having frequency F2, then the field produced by the rotor winding is moving with respect to rotor winding 120 F2 by P. Is it okay? Please tell me. Yes, sir. What is the speed, sir? SNS. And what is the direction, sir? Clockwise only, sir. Because if the stator field is moving in a clockwise direction, it intersects same A phase, B phase, C phase, and the induced EMF in the rotor is also A phase, B phase, C phase, and also creates a clockwise rotating magnetic field. Is it okay? Yes, sir. So, rotor produces a rotating magnetic field with respect to rotor body. Rotor body, or you can say rotor winding. Body and winding both are same. So, speed of rotor field with respect to rotor body is 120 F2 by P. F2 is, already we have SF1. So, F2 is SF1, and you can write SF1 by P, that is 120 F1 by P will become NS. So, 120 into F1 by P into S, that is equals to SNS. Is it okay? So, from here I have represented this to be SNS. Is it okay? Great, sir. Now, please observe. Rotor field is there, and rotor field is also rotating with respect to rotor structure. Now, please see. I am interested to understand speed of rotor field with respect to stator winding. Speed of rotor field with respect to stator winding. So, sir, we are able to understand speed of stator field with respect to stator winding, speed of rotor field with respect to stator winding. I am interested. Now, please observe. We have a stator can't move. So, stator is stationary. Remember that stator is stationary, it can't move. And rotor is free to rotate. Now, please observe here. Because of the current flowing into the rotor winding, rotor will create a rotating magnetic field. Let us suppose this to be the rotor field. So, rotor field with respect to rotor structure is moving at a speed of SNS, 120 F2 by P, where F2 is the frequency of current flowing into the rotor winding. So, that will be equals to SNS. Yes, sir. Or you can say NS minus NR. Already we know about NS minus NR. Sir, Stator is stationary, rotor is moving, rotor body is moving at this particular time at a speed of nr. Yes, sir. So what is the speed of rotor field with respect to stator winding? Sir, rotor field is moving onto the rotor body at a speed of SNS. Rotor body itself moving at a speed of nr. So with respect to stationary stator, rotor field is moving at a speed of SNS plus nr. Are you able to sense this? Please tell me if you are able to analyze this. You can understand, like a person is standing over a station and one person is moving onto a train. Train is moving at a speed of nr and a person is moving on the roof of the train at a speed of SNS. So the person who is standing on the stationary station founds the speed of person who is onto the roof as, sir, SNS plus nr. Is it okay? So, sir, SNS plus nr means, SNS plus nr means, SNS plus nr means, what is nr, sir? We are aware with the term nr, sir. What is nr, sir? nr is basically, from the slip expression, we know that, just making it in a bracket, we all know that slip S is ns minus nr upon ns. So we can arrange this, nr will become ns 1 minus s. Yes, sir. So if you are going to substitute nr as ns 1 minus s, then this will become SNS, SNS, SNS plus nr, SNS plus nr, and nr can be represented as ns minus SNS. So what is the speed? Ns only, sir. It means your rotor field is rotating with respect to stator winding at a speed of ns. Rotor field is rotating with respect to stator winding at a speed of ns. Sir, does rotor field also create induced EMF on rotor winding and stator winding? Yes, it will create. And what is the frequency of the induced EMF created by rotor field, sir? Please observe. Frequency of induced EMF on rotor winding due to rotor field. Frequency of induced EMF on rotor winding due to rotor field. Frequency of induced EMF on stator winding due to stator field. Please tell me, are you able to understand this? Yes, sir. What is the frequency of induced EMF on a rotor winding due to rotor field? P delta n by 120, where delta n is the relative speed between field and winding. Which field and which winding? Sir, rotor winding and rotor field. What is the relative speed between rotor field and rotor winding? Relative speed between rotor field and rotor winding. Relative speed between rotor field and rotor winding, sir, SNS. Relative field between rotor field and rotor winding, sir, SNS. So this is same as F2, sir. Great, sir. What is the frequency of induced EMF on stator winding due to stator field, due to rotor field? Due to rotor field. Due to rotor field. Frequency of induced EMF on stator winding due to rotor field. Again, sir, P delta n by 120. What is the relative speed between stator winding and rotor field? Rotor field and stator winding. Relative speed is ns. So P ns by 120. That is again equals to F1 only, sir. Is it okay? Yes, sir. So frequency of induced EMF due to rotor field or due to stator field onto the rotor body or onto the stator body will remain F1 and F2 only. And that is only possible when stator field and rotor field are stationary with respect to each other at every position. Let me write again. Now, we know about the speed of rotor field with respect to stator winding. Let's talk about speed of please try to feel this, speed of stator field with respect to rotor field. Can you please tell me what is the speed of stator field with respect to rotor field? Please observe. I'm going to explain everything again on the single diagram. Please observe. And please try to understand each and everything properly again, once again. Sir, we have a stator. Stator can't rotate. Stator having 3-phase winding, displaced in space by 120 degree. When stator is being supplied by a supply having frequency F1, then stator creates stator rotating magnetic field. This stator rotating magnetic field rotates with respect to stator structure at a speed of ns. This ns depends upon the frequency of current flowing into the stator winding and number of poles for which stator is being designed. Let us suppose this to be the north of the stator. Yes, sir. While revolving round to the stator, it cuts the rotor conductor and induces EMF in the rotor conductor. That creates rotor pole, and rotor will start rotating in the direction of rotating magnetic field at a speed of, say, nr. nr can be 0, nr can be anything. Okay. At this particular instant, what is the relative speed between stator field and rotor winding? Relative speed between stator field and rotor winding is ns minus nr. You can say this to be sns, sir. Now, depending upon the relative speed between stator field and rotor winding, there will be a induced EMF onto the frequency of induced EMF onto the rotor. The frequency of induced EMF onto the rotor will be P delta n by 120, where delta n is the relative speed between stator field and rotor winding. So, relative speed between stator field and rotor winding is SNS by 120, and that is similar to SF1. Is it okay? Yes, sir. Slip times of the supply frequency. Now, rotor I am assuming also of 3-phase, and the current flowing in the rotor having frequency F2. So, rotor will also create rotating magnetic field, sir. Rotor will also create rotating magnetic field, sir. Let us suppose this to be the rotor south. Rotor rotating magnetic field rotates with respect to rotor structure at a speed of sir 120 into F2 by P, where F2 is the frequency of current flowing into the rotor winding. So this will be equals to SNS only, sir, because F2 is SF1 and 120 F1 by P is NS. Number of poles of stator and rotor is same, sir. Great, sir. Now, speed of rotor field with respect to stator winding. Speed of rotor field with respect to stator winding. Rotor field is rotating with respect to rotor structure SNS. Rotor structure itself moves at a speed of nr. So rotor field with respect to stator body will become sir SNS plus nr. When you solve, it will again become ns only. Is it okay? Yes, sir. So, sir, what is the relative speed between stator field and rotor field? In the air gap, what is the speed of stator field? Ns, sir. Air gap is also considered as a stationary part. Ns, sir. And what is the speed of rotor field in the air gap? Air gap is treated as a stationary. Sir, Ns, sir. So what is the relative speed between stator field and rotor field? 0, sir. And that makes them unable to hold their hand. And keep on applying electromagnetic torque, which is responsible for the movement of the rotor. Is it okay? Yes, sir. So in the air gap, both are rotating at the speed of ns. Onto the stator body, if we take stator body as a common body, stator body as common body, then what is the speed of stator field with respect to stator body? Speed of stator field with respect to stator body ns. Speed of rotor field with respect to stator body ns. What is the relative speed between stator field and rotor field? 0, sir. What is the speed of relative speed between stator field and rotor field? 0, sir. Now one can also take rotor as a common body. So let's talk about rotor as a common body. So rotor as a common body. Rotor as a common body. Please tell me. If I am considering rotor as a common body, then what is the speed of rotor field with respect to rotor structure? Rotor field with respect to rotor structure. Rotor field with respect to rotor structure is SNS. And stator field with respect to rotor structure. Stator field with respect to rotor structure, SNS, sir. So what is the relative speed between them? Sir, 0. So you are able to understand this, sir. Sir, the relative speed between stator field and rotor field must be 0. This is the must condition for any electrical rotating machine to rotate. Because then only there will be a magnetic locking between stator north and rotor south. Otherwise, if there will be 1 RPM difference, then the machine can't rotate. The machine can only rotate if this north and south are rotating at same speed. Either you can observe in air gap or onto the rotor or onto the stator. So what is the must condition for production of steady state electromagnetic torque? In order to produce a steady state electromagnetic torque, the first condition is magnitude of the fluxes must be same. Magnitude of the fluxes must be constant. Same means I am saying just constant. Because if the rotor field is going high or low, then electromagnetic torque increases or decreases. So magnitude of the fluxes must be constant. First thing. Second thing, the relative speed between them must be 0. The relative speed between them must be 0. Then only a continuous unidirectional electromagnetic torque will be there. Third one is there must be some angular displacement between stator and rotor poles. It means there must be some angular displacement between the two fluxes. Then only electromagnetic torque, your steady state electromagnetic torque will exist. Is it okay? Are you able to understand up to this part? So why the rotor is rotating? Who rotates this rotor? This is the invisible magnetic locking. You are not able to see this, but this is what a rotor is going to be rotated in the direction of rotating magnetic field. Now at any speed, please try to understand what this F2 is equals to SF1. Very important. Please observe. Now at any speed, let us suppose a moment when rotor is stationary. Please try to understand. The south need to hold the hand of north. Let us talk about when rotor is stationary, when NR is 0. When NR is 0, then frequency F2 will be equals to, when NR is 0, then NS minus NR will remain NS only. Frequency of induced EMF F2 will be equals to F1 only. It means the speed with which stator field is moving, same speed is needed for a rotor field to move over a stationary rotor. Okay, sir? Is it okay? Yes, sir. Now, when NR start rotated, suppose half of the synchronous speed. So for half of the synchronous speed, now you can find slip speed. Accordingly, there will be a frequency. And as the rotor speed increases, in order to keep the hand holding, if the surface on which rotor field is moving, if the surface is moving at a speed of NR, then the speed of this field needed onto the rotor body is NS minus NR, sir. So it means as fast as rotor will start rotating, the rotor field with respect to rotor body, speed is reducing in order to keep the hand holding. Is it okay? So at every speed you found that NS north of the stator and south of the rotor will remain stationary with respect to each other. So please see, I am going from the initial part again. Please see. Suppose we have a stator here. This is a 3-phase stator displaced in space by 120 degree. And this stator is being supplied by 3-phase current displaced in time by 120 degree. So what happened when a 3-phase stator displaced in space by 120 degree is being supplied by 3-phase current displaced in time by 120 degree? Sir, when a 3-phase stator displaced in space by 120 degree is supplied by 3-phase current displaced in time by 120 degree, then a rotating magnetic field comes into the picture. This is what we called stator rotating magnetic field, which rotates onto the stator body, Is it okay? The speed of this field depends upon the frequency of current flowing into the stator winding. Yes, sir. So I have represented this. Please observe here. I'm just opening this stator. Okay, sir. And this is a stator. So stator cannot rotate. Yes, sir. Stator is stationary. Stator cannot rotate. So here I am representing stator cannot rotate. And we have a stator having 3-phase. So 3-phase stator winding I am representing. So these 3 windings are being displaced in space by 120 degree. And frequency of supply given to stator winding is F1. So because of this supply frequency F1, there will be a stator rotating magnetic field onto the stator winding. So this field is rotating with respect to stator winding. This field is rotating with respect to stator winding at a speed of ns, where ns is 120 F1 by P. The direction of rotation of this field depends upon the phase sequence of supply. Is it okay? Yes, sir. So we have created a field north and south, and this field is rotating with respect to stator winding. This field is rotating with respect to stator winding. The current flowing into the stator winding creates this rotating magnetic field, and this field is rotating with respect to stator winding at a speed of ns, where ns is 120 F1 by P, and the direction of rotation of this field depends upon the phase sequence of supply. Let us suppose you have given a phase sequence A phase, B phase, C phase, so it is rotating in a clockwise direction. Is it okay? Yes, sir. Great, sir. So I am representing this north as a person. So the field is rotating with respect to rotor, with respect to stator winding at a speed of ns. Is it okay? Are you able to visualize this? Yes, sir. While rotating round to the rotor, while rotating round to the stator, it cuts the rotor structure. It cuts the rotor structure. Rotor is also of 3-phase. Rotor is also of 3-phase. Yes, sir. So it cuts the rotor structure. Yes, sir. While rotating round to stator, it cuts the rotor structure. Yes, sir. When it cuts the rotor structure, while rotating round to stator, it cuts the rotor structure. Are you able to visualize? Yes, sir. While rotating round to stator, it cuts the rotor structure. Rotor is free to rotate, so rotor start rotating at a speed of nr. Here I am trying to show the rotor also. Please try to understand each and every part. This is a rotor. Rotor also designed with, suppose, 3-phase winding, and while stator revolving round to stator, while stator field revolving round to stator, cuts the rotor structure. Okay, yes, sir. So when it cuts the rotor conductor, then as per the Lenz's law, there will be an induced EMF onto the rotor. And that induced EMF drives current, which creates rotor pole, and rotor will start it in the direction of rotating magnetic field. Let us suppose the rotor will started at a speed of nr. So when rotor will be started at a speed of nr, when rotor will be started at a speed of nr, when rotor will be started at a speed of nr, then at that particular time, what is the speed with which stator field is linked with the rotor winding? Sir, ns minus nr. Is it okay? Yes, sir. This ns minus nr is called, oh, my board is creating an issue. ns minus nr is called relative speed between stator field and rotor winding. Yes, sir. And that will create a frequency of induced EMF onto the rotor. The frequency onto the rotor, induced EMF frequency onto the rotor is P delta N by 120, where delta N is the relative speed between stator field and rotor winding. What is the relative speed between stator field and rotor winding? Sir, ns minus nr. So ns minus nr is your delta N. Now you can clearly observe here that this will become, sir, SF1. Is it okay? Because ns minus nr can be represented as SNS and SNS. NS is 120 F1 by P, so we will get S1 SF1. Is it okay? Yes, sir. Now please observe. Because rotor is rotating and stator field is rotating, but stator field is rotating at a higher speed than rotor field. So there will be a induced EMF onto the rotor winding as A phase, B phase and C phase. First, let us suppose it cuts A phase, then B phase, then C phase. So there will be an induced EMF onto the rotor, and that induced EMF displaced in time by 120 degree. It comes A phase, after 120 degree of time it cuts to B phase, and after 120 degree in time it cuts to C phase. That time depends upon the relative speed between stator field and rotor winding. Is it okay? Yes, sir. Now, because the windings is 3-phase and the current flowing in the winding is also displaced in time by 120 degrees, so rotor also create rotating magnetic field. Yes, sir. Now rotor also create rotating magnetic field, and I am going to represent the rotor field in this way. This is your rotor north, and this is, say, your rotor south. Is it okay? Yes, sir. This is your rotor north and rotor south. Rotor field is rotating onto the rotor body at a speed of, please see, the frequency of current in the rotor winding is F2. So rotor creates a field which is rotating onto the rotor body at a speed of 120 F2 by P. That is nothing but SNS only. Is it okay? Are you able to understand this? Which is nothing but SNS only. Because current flowing in the rotor winding having frequency F2. Yes, sir. Now this will be your rotor south and this will be your stator north. Is it okay? Yes, sir. Stator north is rotating. Let me show you rotor south little bit behind this. So, because I have represented this as a direction. So this will be your rotor south and this will be your rotor north. Now rotor south holds the hand of rotor stator north. Both are moving at same speed. This rotor south, stator north, rotor north and stator south holds the hand. So because of this, there will be a movement, and that movement continues till this hands are being attached. Yes, sir. That is what we call magnetic locking, because with respect to each other, both are stationary. Onto the rotor body, stator field is rotating at a speed of SNS, and rotor field is also rotating at a speed of SNS. So the relative speed between this stator north and rotor south is 0. Even if you want to observe onto the stator, then rotor field is rotating onto the rotor body. This is your rotor field. This is your rotor field. Please observe here. This is your rotor field. This is your rotor field, which is rotating onto the rotor body. This is your rotor field, which is rotating onto the rotor body. Rotor body is stationary. This is a rotor field, which is rotating onto the rotor body. Please try to understand. Okay, sir. This is a rotor field which is rotating onto the rotor body. So, rotor field is rotating onto the rotor body at a speed of s and s. So, there will be a induced DMF in the rotor winding also. And the frequency of induced DMF is P delta N by 120, where delta N is the relative speed between rotor field and rotor winding. So what is the relative speed between rotor field and rotor winding? Yogendra, you have asked this. So the relative speed between rotor field and rotor winding is, sir, S N S. So frequency of induced DMF will become P into S N S by 120. That is again equals to SF1 only. Is it okay? Yes, sir. And now this field is moving with respect to rotor winding at a speed of S and S. Rotor itself is moving at a speed of NR. Then with respect to stationary winding, the speed of rotor field will be, sir, S NS plus NR. You can visualize. Think that you are moving on some surface. Let us suppose you are moving on some surface and the surface is also moving. If the surface is moving in the forward direction and you are also moving in the forward direction, then your speed with respect to a person standing on a stationary surface will be, sir, your speed plus the surface speed on which you are moving. Both are going to be added. So both are going to be added. Is it okay? And the total speed will again equals to ns only. It means the speed of stator field with respect to stator body ns, speed of rotor field with respect to stator body is also ns. So what is the relative speed between stator field and rotor winding? Stator field and rotor field. The relative speed between stator field and rotor field is 0. And that is the must condition for production of steady state electromagnetic torque. That is the must condition for production of steady state electromagnetic torque, without which a electrical rotating machine can't rotate. Without which a electrical rotating machine can't rotate. It can be clearly understood with a simple experiment. Please observe here. Suppose I have a ball bearings here. These are the balls. These are the ball bearings. Okay? Yes, sir. Let me make the inner one with a white color, outer one with a green color. Suppose I have a rim with which I am going to connect this inner surface. Okay? And I have a rim with which I am going to connect the outer surface. Okay? Suppose these are the rims with which I am going to connect the inner and outer surface. Okay? Yes, sir. These two rims are not connected physically. There are two different smaller rings. A smaller ring will be connected with the green one. Okay? And the outer ring, the green ring, or I am changing the color as pink only. The pink ring is connected with the pink one. Okay? Both the surface can rotate. But if you are going to rotate the inner one, then there will be no action onto the outer one. Now I am going to hold some permanent magnet here. Just to show you, please observe. Please try to understand. I am going to show you some permanent magnets here. And the magnets having polarity of north on the downward side. Okay, sir. And there is one more magnet here having south. This will be, there will be a magnets connected here. These are the permanent magnets. Let us suppose for a moment. These are the permanent magnets. Okay. Yes, sir. They have a polarity north, south, and I have the inner surface. Inner surface has also the magnets connected in this fashion. Say the inner surface also has magnet connected in this way. This will be north. This will be south. This will be north. and this will be south. Okay. The things can move. Yes, sir. The inner rim and outer rim can move. They are not attached directly. They are attached with the ball bearings, outer and inner surfaces. Okay. What happened if I leave at this particular stage? Sir, if you are going to leave at this particular stage, the inner rim will get moved because of the magnetic attraction between north and south. So this is going to be moved a small angle. Is it okay? Yes, sir. It will move to a small angle when this south comes to closer to this north, north, south, south, north, north, south. Now please imagine. The inner rim is moved. Inner rim is a rotor. Now please imagine if I am going to rotate this outer rim. What happens with the inner rim? Sir, inner rim is start chasing the outer rim. Is it okay? Yes, sir. But this is only possible when the relative speed between these two is 0. Suppose if the relative speed between these two is not 0, then what happened? Sir, this will move ahead. And if it lags in moving at the same speed, then presently the torque appeared will be in the clockwise direction, but once it will move ahead from this north, then the torque will become anti-clockwise direction. So further the movement is not possible. The movement is possible with the outer rim. The inner rim can move only when the relative speed between these two will maintain 0, and that is what we call magnetic locking between stator pole and rotor pole. Is it okay? So whether this is a necessary condition or not? Now with the 3-phase induction motor, the greatest advantage is we need not to rotate. We just need to supply a 3-phase to a 3-phase balanced stator. It will create a rotating magnetic field by itself. And this rotating magnetic field rotate while revolving round to rotor. It cuts the rotor conductor, induces EMF and creates rotor pole. The rotor pole is also rotating. And we have observed that the two fields are rotating at the same speed. So the magnetic locking between the stator north and rotor south will remain maintained, which is necessary for the movement of the machine. Is it okay? So what is the must condition for any electrical rotating machine to rotate? Sir, the must condition for any electrical rotating machine to rotate is relative speed between stator field and rotor field must be 0. Relative speed between stator field and rotor field must be 0. So let's have a important point. Write down. Condition for production of steady state electromagnetic torque. Condition for production of steady state electromagnetic torque. Is it okay? Yes, sir. So you know about the condition. Sir, the magnitude of the fluxes must be constant. Otherwise, the torque will be harder, or a torque will be softer. If the north and south pole magnitudes are changing, then sir, sometimes north is stronger, then it will pull south to a harder way. You can say more torque or less torque. So that torque is a pulsating type torque, or you can say not a constant magnitude torque. In order to have a steady state electromagnetic torque, first thing is magnitude of the fluxes must be constant. Second thing is stator and rotor field must be stationary with respect to each other. Stator and rotor field must be stationary with respect to each other. Third is there must be some angular displacement between the two fluxes. Let me complete all the 3 cases just as fast as I am completing all the 3 cases, you are going to fall in love with this machine. So these are the condition for production of steady state electromagnetic torque. Now come to the condition number 2. What is condition number 2, sir? Condition number 2 is only applicable to the slip ring induction motor, because only in slip ring induction motor it is possible to give supply onto the rotor side. Yes, sir. So I am talking about case number 2. When 3-phase supply is given to rotor, When three-phase supply is given to rotor of slip ring induction motor, and stator is shorted. When three-phase supply is given to rotor of a slip ring induction motor and stator is shorted. When three-phase supply is given to rotor of a slip ring induction motor and stator is shorted. Please observe, this is the second case. Just after third case, you are going to get 100%. Okay, so you need to keep patience till third case. Okay, then onward you will become master in this. Please see. Stator 3-phase and we have rotor also 3-phase. Stator 3-phase and we have rotor also 3-phase. So this will be your A phase, B phase and C phase. 3-phase rotor side is supplied with the help of slip rings. I'm just representing directly instead of writing all these things. So 3-phase supply is given to rotor. 3-phase supply is given to rotor, say at F1 Hertz, and stator is shorted. Stator is shorted. 3-phase supply is given to rotor and stator is shorted. Okay. 3-phase supply is given to stator and rotor is shorted. Please tell me what happened when a 3-phase displaced winding supplied by a 3-phase current displaced in time by 120 degree having frequency F1. It will create a rotating magnetic field, sir. So under this condition, when the supply is given to a rotor, rotor will create a rotating magnetic field, sir. So I am writing here speed of rotor field, with respect to, just starting in a smaller, with respect to rotor body. So speed of rotor field with respect to rotor body. Sir, body means winding. Body and winding both are same thing. Structure, body, winding, all are same. So speed of rotor field with respect to rotor body is ns, sir. That will be equals to 120 F1 by P. Now, it depends upon the phase sequence of supply. It can be a clockwise or it can be a anti-clockwise. It depends upon the phase sequence of supply. So I am assuming it to be a clockwise direction. Okay. Let us suppose the phase sequence of supply is such that it is in a clockwise direction. So this is the speed of rotor field with respect to rotor body. Speed of rotor field with respect to rotor body. Is it okay? Now please see. We have a rotor and rotor winding is displaced in space by 120 degree. We have given supply to the rotor and that will create a rotating magnetic field. Yes, sir. That will create a rotating magnetic field. Yes, sir. Please try to understand here. That will create a rotating magnetic field. Okay, sir. Please try to analyze here. You need not to note this one. You just need to note the last page. Okay. Have you noted this? Okay. Now just try to understand here. We have a stator. Okay, sir. Let me show you a stator with only two conductors, A and A dash. This will be your A and this will be your A dash. Okay. Yes, sir. We have a rotor. We have a rotor. And sorry. Suppose we have a rotor here. Okay, sir. We have a stator here. Okay, sir. Please observe here. When a three-phase supply is given to rotor, then there will be a rotating magnetic field onto the rotor. This rotating magnetic field rotates onto the rotor surface. The rotor surface is not rotating. This rotating magnetic field is rotating onto the rotor surface. Yes, sir. We have a rotating magnetic field which rotates onto the rotor surface. This rotating magnetic field rotates onto the rotor surface. Is it okay? Okay. So rotating magnetic field is rotating onto the rotor surface. Rotor surface is not rotating, only the field is rotating onto the rotor surface. Okay, sir. Now one can easily understand it is quite difficult to maintain everything. See, now one can easily understand, sir, while rotor field is rotating with respect to the rotor body, it cuts the stator conductor. Yes, sir. Now, at this particular instant, if it is rotating in a clockwise direction, then at this particular instant, what will be the induced EMF onto the stator A and A dash? If this will be the direction of rotor field with respect to the rotor structure is stationary. If the field is moving with respect to the rotor structure, then what will be the induced EMF at A and A dash? Sir, as per the right hand palm rule, we know that whenever field is moving, stop the field and rotate the conductor in the opposite direction. So if the field is moving in this direction, stop the field and assume the conductor is moving in this direction. This will be your north. So this will be your inward and this will be your outward. Inward means, what is inward means? Inward means, sir, by right hand curl rule, if the current flows in the direction of right hand thumb, then right hand curl is the direction of magnetic field. So it means stator is going to create a magnetic field in this way. Stator is going to create a magnetic field in this way. Stator is going to create a magnetic field in this way. Is it okay? Yes, sir. So stator is going to create a magnetic field which is going to path in this way. This will be your north and this will be your south. Yes, sir. Now please observe, in case if stator is allowed to rotate, then stator will start rotating such that relative speed between rotor field and stator winding decreases. If the stator is allowed to rotate, then stator will start rotating in such a direction so that relative speed between rotor field and stator winding reduces. It means it will start rotating in a clockwise direction. This north attracts towards this south and it will start rotating in a clockwise direction. But you haven't allowed a stator to rotate. You blocked this stator position by having different nuts and bolts. So stator can't rotate. And you make rotor to be free to rotate. So what happened? Sir, if you block the stator and rotor is free to rotate, then rotor field is moving in a clockwise direction, but this south attracted toward this north, and rotor will start rotating in a anti-clockwise direction. Rotor will start rotating in a anti-clockwise direction. Is it okay? So whenever we are going to give a supply onto the rotor side, rotor will start rotating opposite to the direction of rotating magnetic field. Why? Because stator can't rotate and rotor is free to rotate. So always the rotation will be in such a way that it reduces the relative motion between winding and field. Is it okay? Yes, sir. So please see, I am writing here. Please observe here. Up to this part, I am hoping everything is clear. speed of rotor field with respect to rotor body. Speed of rotor field with respect to rotor body. Ns, that is 120 F1 by P. Is it okay? Yes, sir. Now, the induced stator EMF drives current. The induced stator EMF drives current as per Lenz's law, or let me write in a different way. Let me write in a different way. The induced stator current, the induced stator current opposes the relative motion between according to Lenz's law, the induced stator current must oppose relative motion between rotor field and stator winding. Between rotor field and stator winding. Thus, rotor started in opposite direction to rotor field. Are you able to understand this? Sir, we all know that the polarity of induced EMF, the induced EMF is onto the stator. The polarity of induced EMF must be such that it will oppose the cause. Cause is clockwise moving field. So the only possibility that stator also rotate in a clockwise direction, but stator can't rotate. You have stopped the stator. However, rotor can rotate. Rotor field is moving onto the rotor body. So if rotor start rotating in the opposite direction, let us suppose at synchronous speed, then your rotor field onto the rotor body looks like stationary, sir. Sir, if rotor is moving at ns and field is moving at ns, then what is the speed for a stationary stator conductor? 0, sir. If I am moving on some surface in a forward direction and surface itself moving in the backward direction, and if our speed is same, then a person standing over a stationary surface found me as a stationary person who is trying to move forward, but the surface itself moves backward. Is it okay? Yes, sir. Yes, sir. Up to this part, I am hoping everything is clear. So whenever we are going to give a supply to the rotor, then rotor will start rotating opposite to the direction of rotating magnetic field. Is it okay? Up to this part, everything is clear? Yes, sir. Now let the speed of rotor be nr. Let speed of rotor be nr. In which direction? Sir, in a anti-clockwise direction. It will start rotating in a anti-clockwise direction. If field is in a clockwise direction, then nr is in a anti-clockwise direction, sir. So that is the speed of rotor in an anti-clockwise direction, that is nr. Now please observe. Let me know What is the speed of? Have you noted up to this part? Now please observe here. Now please observe here. Speed of rotor field with respect to stator winding, or you can say body, structure, body, winding, everything is same. So sir, we have stator, we have rotor. Rotor is 3-phase and rotor is being supplied by a frequency F1. So there will be a rotor field which rotates with respect to rotor body at a speed of ns. That will be 120 F1 by P. Now this rotor field cuts the stator conductors. This rotor field cuts the stator conductor. Always remember, stator can't rotate. This rotor field cuts the stator structure. Yes, sir. And try to rotate the structure stator ahead. But since stator can't rotate, but rotor is free to rotate, so rotor will start rotating in opposite direction at a speed of nr. Now when rotor is rotating here and rotor field is rotating out in the direction opposite to the rotor movement, then you can say, sir, the relative speed between rotor field and stator winding will become ns minus nr. Please tell me, are you able to understand this? What will be the relative speed, sir, between rotor field and stator winding? Rotor field is moving onto the rotor body at a speed of ns in forward direction. Rotor itself moving in the reverse direction. So at what is the speed with which rotor field is intersecting stator conductors? Assume that this is a ramp and a ramp is going downward and you are trying to move upward. Ramp is coming downward. So a stationary thing, relative to a stationary thing, what will be your speed? Sir, this will be ns minus nr only. Is it okay? Please tell me. Yes, sir. So now this will be ns minus nr. The relative speed between rotor field and stator winding. Relative speed between rotor field and stator winding will be ns minus nr, and that is called as sns, sir. Is it okay? Yes, sir. So with a speed of sns, it first intersect A phase, then it intersect B phase, and then it intersect C phase. Rotor poles are moving, so first they are going to cut A phase. After 120 degree of rotation, they will cut B phase, and after 120 degree of rotation, they will cut C phase. Is it okay? Yes, sir. So we can say, sir, the induced EMF onto the A phase maximum, after 120 degree in time B phase maximum, after 120 degree time C phase maximum. So here you can say, sir, the induced EMF on stator will be A phase, B phase and C phase. And what will the frequency of the induced EMF? Sir, frequency of induced EMF will be frequency of induced EMF in stator due to rotor field. Please tell me, frequency of induced EMF in stator due to rotor field. Sir, that is P delta n by 120. And what is delta n? Relative speed between rotor field and stator winding. Relative speed between rotor field and stator winding. What is the relative speed between rotor field and stator winding? SNS. So this will become P into SNS by 120. Let it be frequency F2. That is the frequency in the shorted winding. So frequency of induced EMF, 120 × 10⁻⁷ 2 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ 4 × 10⁻⁷ induced EMF in rotor due to rotor field. Please tell me frequency of induced EMF in rotor due to rotor field. Sir, again it depends upon P delta N by 120, where delta N is the relative speed between field and winding. Which field and which winding? Rotor field and rotor winding. What is the relative speed between rotor field and rotor winding? What is the relative speed between rotor field and rotor winding? Sir, NS. So relative speed between rotor field and rotor winding is NS. So I can replace here P into NS by 120. Let it be F1 only, because this is F1 only. From equation 1 and 2, let it be equation 1 and let it be equation 2. From equation 1 and 2, you can say, sir, from equation 1 and 2 we have F2 to be equals to F2 by F1. From equation 1 and 2 we can write, sir, F2 by F1 as NS minus NR upon NS. That will be S, sir. So frequency of induced EMF in the shorted stator is slip times of the frequency of supply to the rotor. Is it okay? Frequency of induced EMF in stator due to rotor field, frequency of induced EMF in rotor due to rotor field. So relative F2 by F1 will become slip times of frequency. Sir, frequency in EMF in rotor once again. Frequency of induced EMF in rotor due to rotor field. See, frequency of induced EMF is always P delta N by 120. Yes, sir. Frequency of induced EMF is always P delta N by 120. What is delta N? Relative speed between field and winding. So, which field and which winding? Sir, rotor field and rotor winding we are talking about. So, what is the relative speed between rotor field and rotor winding? Speed of rotor field with respect to rotor winding is the relative speed between rotor field and rotor winding. That is NS only, sir. Yes, sir. So I am just substituting NS here. That is same as the supply frequency F1. So the ratio of F2 by F1 will again become SF1 only. So it means it doesn't matter whether you are giving a supply to stator or rotor. The frequency of induced EMF in the shorted winding is always equals to slip times of supply frequency. Is it okay? Yes, sir. Now please observe. Since stator is three-phase, sir, stator is three-phase, and current flowing in stator is also three-phase, displaced in time by 120 degree, having frequency F2. Yes, sir. So it means stator will also create a rotating magnetic field, sir. Sir, stator is three-phase. Three-phase stator displaced in space by 120 degree. Displaced in space by 120 degree carries and current in stator and induced current in stator displaced in time by 120 degree and induced current in stator displaced in time by 120 degree having frequency F2. Thus, stator produces rotating magnetic field. Is it okay? Great, Sarji. Stator is going to create a rotating magnetic field. Please tell me what is the speed? What is the speed of stator field? So speed of stator field with respect to stator winding or stator body. You can say body, structure or winding, all are same. So please tell me What is the speed of stator field with respect to stator winding? Sir, the speed of field produced by the current flowing in the winding always depends upon the frequency of current in the winding. So what is the frequency of current in the winding? Sir, stator having frequency F2. Number of poles of stator and rotor are same. So this will become 120 F2 by P. And what is F2? F2 is equals to SF1, and you can write, sir, SNS. Yes, sir. And in which direction? Sir, if the rotor is rotating, if the rotor field is rotating in a clockwise direction, then it will create A phase, 120 degree apart B phase, 120 degree apart is your C phase. So the induced EMF will going to be maximum in A phase, then B phase, then C phase. It means your stator field is also rotating in a clockwise direction. So stator field is also rotating in a clockwise direction. Is it okay? Yes, sir. Rotor field is rotating in a clockwise direction. Rotor is rotating in an anti-clockwise direction. Stator field is also rotating in a clockwise direction only. Is it okay? Because phase sequence of induced EMF in stator is same as the direction of rotation of the rotor field. Hoping up to this part everything is clear. Great, sir. Now please observe. Please tell me speed of stator field with respect to rotor body. Speed of stator field with respect to rotor body or winding, both are same. Sir, speed of stator field with respect to rotor body. Please tell me. Let me write in the next page. Or you can just make it a little bit smaller. It is visible? It is visible? Okay. So speed of stator field with respect to rotor body. Sir, please observe here. Sir, speed of stator field with respect to rotor body. Please observe, sir. Rotor body is moving in this direction at a speed of nr, and stator field is rotating in a clockwise direction at a speed of, with respect to stator, at a speed of SNS. So field is moving in a clockwise direction and rotor is moving in an anti-clockwise direction. So can you find the speed of stator field with respect to rotor body now? What is the speed of stator field with respect to rotor body? Please try to assume I am opening my car door. I am keeping my car back and you are coming in front of door with a speed nr. Car is going back with a speed of SNS. So at what speed you are going to be hit by the car? Sir, the two speeds are going to be added. The two speeds are going to be added. It means SNS plus NR. Is it okay? If we are going in the same direction, the two speeds are subtracted. If we are coming opposite, the two speeds are added. Is it okay? So what is the speed, sir? NS plus NR. We know that NS plus NR is equals to NS only, because NR is NS 1 minus S. So we have a speed of stator field with respect to rotor body. So what is the speed of stator field with respect to rotor body? Sir, it is same as the speed of rotor field with respect to rotor body, and it is the mandatory condition. Now please observe. I'm hoping up to this part you have noted. Just if you have noted, I'm going to explain each and everything on the last figure. Yeah, this topic needs time. You have to go one or twice. Revision is needed for this topic, but this topic is just going to change your entire vision of the electrical machine. It's my bet. You are going to change your vision towards this subject. You are going to fall in love with this subject. Please see. Please see. We have a stator. I'm going to show you each and everything on the final diagram. Please see. Please try to understand and answer me each and everything. Please try to understand as well as answer my all questions. Okay. We have a stator. Stator can't move. Stator can't move. We have a rotor. Stator is 3-phase winding, displaced in space by 120 degree. Rotor also have 3-phase winding displaced space by 120 degree. You have given supply to the rotor at a frequency of F1. When a 3-phase winding displaced in space by 120 degrees supplied by a current having frequency F1, it will create a rotating magnetic field. So now we have a rotor rotating magnetic field. So we have a rotor rotating magnetic field. Let it be rotor north. Rotor field is rotating with respect to rotor body at a speed of ns, where ns depends upon the frequency of current flowing into the rotor winding, and the direction of rotation depends upon the phase sequence of supply. So let us suppose rotor field is rotating onto the rotor body at a speed of ns. Yes, sir. While revolving at a speed of ns, it cuts the stator structure, induces EMF in the stator structure. As per the Lenz's law, the rotor must rotate in such a direction that it will oppose the relative motion between stator winding and rotor field. For that, rotor gets started in the opposite direction at a speed of nr. Rotor gets started in the opposite direction at a speed of nr. Is it okay? Yes, sir. It can't rotate at synchronous speed, because at synchronous speed what happened? There will be no flux cutting onto the stator. There will be no stator induced EMF, no stator current, no stator pole. When there is no stator pole, there is no torque, and no body can rotate without any force. So rotor can't rotate at synchronous speed. Is it okay? It will only rotate at a speed less than synchronous speed. Let us suppose it is rotating at a speed of nr. Now, while revolving at a speed of nr at this particular time, what is the speed with which rotor field is linking with the stator body? Sir, rotor field is moving onto the rotor body at a speed of ns, and rotor body itself moving opposite direction at a speed of nr. So the relative speed between rotor field and stator winding will become ns minus nr. ns minus nr means, sir, sns, that is what we call slip speed. This is the speed with which stator body is slipping out from the rotating magnetic field of the rotor. Great, sir. Now, because of this slip speed, there will be a induced EMF onto the stator, and the frequency of induced EMF onto the stator will be, sir, P delta n by 120. This depends upon the relative speed between rotor field and stator winding. So the rotor field and stator winding relative speed is, sir, S ns by 120. Ns is 120 f by p, so this will become sf1. Yes, sir. So frequency of current in the stator winding is sf1. Now, while moving the rotor field, it cuts A phase, B phase, C phase. So there will be an induced EMF onto the stator displaced in time by 120 degree, and current flowing in the rotor having frequency f2 displaced in time by 120 degree. Therefore, it will create stator rotating field. So stator also create a rotating magnetic field. The stator rotating magnetic field, let us suppose a south pole, is rotating at a speed of, sir, it depends, the speed of the stator field depends upon the frequency of current flowing in stator. So what is the frequency of current flowing in stator? F2. So, sir, this will rotate at a speed of 120 F2 by P. That will be equals to, sir, S ns only. Is it okay? Yes, sir. Now, what is the speed of stator field with respect to rotor body? Sir, stator field with respect to stator body running at a speed of SNS, rotor is running at a speed of NR. So, the stator field with respect to rotor body will become SNS plus NR, that is again NS only, sir. Now, please observe, what is the speed of stator field with respect to stator body? SNS. What is the speed of rotor field with respect to stator body? SNS. So stator field and rotor field are stationary with respect to each other. Now please come to the air gap. What is the speed of stator field in the air gap? SNS. What is the speed of rotor field in the air gap? SNS. So what is the relative speed between stator field and rotor field? 0, sir. Come to the rotor body. What is the speed of rotor field with respect to rotor body? NS. What is the speed of stator field with respect to rotor body? NS. So it means the relative speed between the stator field and rotor field is 0. That indicates, sir, there will be an electromagnetic torque. But please observe, Both the fields are moving in this direction, but the electromagnetic torque exists in this direction, and that is why your rotor is attracted here. So while they are moving here, your stator field is just pulling rotor north. Stator south is pulling rotor north, and that is why your rotor is moving in the opposite direction. Always remember, your rotor north is attracted towards stator south. Is it okay? Great, sir. So both are moving in this direction, but the electromagnetic torque is in this direction. And that electromagnetic torque and that holding of hand that I have represented is responsible for the motion of the rotor. So what is the relative speed between stator field and rotor field? 0, sir. What is the relative speed between stator field and rotor field? 0, sir. That is the must condition for production of steady state electromagnetic torque. Sir, speed of stator field with respect to rotor field. Speed of stator field with respect to stator rotor field is 0, sir. You can either observe onto the stator body, you can either observe onto the rotor body, you can either observe in the air gap. Are you able to understand? Please tell me. So we have learned two things. In case if the supply is given to stator, then the fields are rotating with respect to stator ns, with respect to rotor SNS, and with respect to each other 0. When supply is given to rotor, then when supply is given to rotor, then with respect to stator SNS, with respect to rotor NS, and with respect to each other 0, sir. Is it okay? Is it okay? Are you able to understand up to this part? Is this diagram method is sufficient? Are you able to understand the diagram method? Now the third case is going to elaborate everything 100%. Let's talk about the third case, when supply is given to both stator and rotor. Sir, such case is also possible? Yes. Now this case makes you able to 100% understand all the concepts. Please see, doubly fed 3-phase slip ring induction motor. This is your doubly fed 3-phase slip ring induction motor, case number 3. Under the heading of doubly fed 3-phase slip ring induction motor. You know, nowadays the cleanest energy is the wind power. Solar panel, it is not clean because e-waste. Because of the e-waste, after 20 years or after 25 years, what we do with the electronic waste? We can't put it outside of the earth. Also, we don't have enough amount of the fuel to burn because already earth environment is highly affected. But there is one clean energy without disturbing the aquatic life, without disturbing anything. We can generate power with the help of wind turbine. Wind turbine uses doubly fed induction generator. It is just a doubly fed induction machine. You can use it as a generator or as a motor. So these are the motors which are going to rule over the upcoming renewable energy resources era. And it is definitely, still it is quite difficult to manage the pitch and all, but soon it will be possible to generate maximum power with the help of, maximum clean power with the help of doubly fed induction generator. The only difficulty is with the reactive power. It can only generate active power. It's a limitation. It can only generate active power. So we need to manage reactive power. Okay. That is the only limitation. Now please observe case number 3. So in case number 3, 3-phase supply is connected to stator as well as rotor at different frequencies. 3-phase supply is connected to stator as well as rotor at different frequency. Okay. I need one help from your side. Please go through the revision of the relative speed concept along with the concept of rotating magnetic field at least once. Just you need to go through your notes. Just you go through the notes. 1 or 2 times if you are going through the notes, it will be sufficient. The points that I have highlighted will get striked in your mind. Once it will be striked, you will be clearly able to differentiate about the different relative speeds and the frequency of induced EMF. Okay. Hoping you have enjoyed this lecture. Thank you everyone. Thank you everyone. Love you all. Good night.